Good morning all. Today I'll be handling the topic memory management, and memory management is one of the features of the operating system, and other features are process management, file management, IO management that we already discussed. In this class we'll be discussing in detail about memory management. Before going to the actual topic, let me tell about memory. There are different levels of memory, and the memory that is very close to the processor is known as the registers, and registers normally we are using for storing operands during execution. And next to registers comes the cache memory, and next to cache memory, that is the main memory. Main memory is also known as physical memory, and it is also known as RAM. And cache memory is a subset of the main memory. And when we write any program, we will be using an editor, and we will be writing the program in the editor. After writing the program, we will be saving that, and at the time of saving, it will go and reside in the secondary storage device. And in order to execute that program, that must be loaded or taken into the primary memory from the secondary storage device. Now after saving, it is residing in the secondary storage device. For execution, we need to bring to the primary memory. So how the operating system is going to, or how the operating system will manage the primary memory efficiently and effectively. That is the thing we are going to discuss in the topic memory management. So I will tell you how the memory, primary memory or physical memory or RAM is logically partitioned. So it is partitioned logically, or it is partitioned into two. One is known as the system area of memory, another one is known as the application area of memory or user area of memory. And in system area of memory contains operating system and other system softwares. At the time of execution, that program that is residing in the secondary storage device will be loaded into this portion of memory, that is the application area of memory, not to the system area of memory. And before execution, that must be compiled. At the time of compilation, that program will be taken into the system area of memory because the compiler resides in the system area of memory. And once the compilation is over, it will generate the object code. That object code go and reside in the secondary storage device. There is one job pool or job queue. So from job queue, the loader, that's a part of the operating system, will be loading that program into the application area of memory. So for managing, in order to manage this area of memory, that is application area of memory, there are different strategies that we will be discussing in this class. So the different strategies are contiguous memory allocation and non-contiguous memory allocation. Different strategies are contiguous memory allocation and non-contiguous memory allocation. And you can see that this is the entire memory management module, and it is partitioned into two types: contiguous memory allocation and non-contiguous memory allocation. And there are two methods in contiguous memory allocation, and they are fixed partition and variable partition. We'll be discussing about fixed partition in this class. Fixed partition again is divided into two, that is fixed equal size partition and fixed unequal size partition. So we'll start with fixed equal size partition. This is main memory or physical memory or RAM, all are same only. So this is the user area of memory, user area of memory, and this is the system area of memory. And we are going to apply system area of memory. We are going to apply contiguous memory allocation. That means in contiguous memory allocation itself, there are two methods, fixed and variable partition. So we'll be discussing fixed partition. In fixed partition itself, two types, fixed equal size and fixed unequal size. So now we'll be discussing with the topic fixed equal size partition. Fixed equal size partition. Fixed equal size partition. So in fixed equal size partition, the user area of memory is partitioned into different memory blocks. And from the name itself we can understand it is fixed equal size. That means the size of each memory block is same. Suppose the size of one memory block is 8K The size of all blocks are same. That means the size of next block also 8K, the size of this block also 8K. That means equal size partition, equal size. And why we are calling this fixed? Once it is partitioned, we cannot change the size of the memory block. We cannot change the size of the memory block. Once it is partitioned, that remains same. That remains same. Now we'll discuss one problem, how the processors from secondary storage device is loaded or placed into these partitions. So suppose we have three processors, P1, P2 and P3, and the size of P1 is 8K and the size of P2 is 6K and the size of P3 is 9K. Now we have three processors, P1, P2 and P3. All these processors are residing in the secondary storage device, and when these processors are residing in the secondary storage device, that time we cannot call it is a process, that time we can call it as program only. Once it is loaded into primary memory, that time only we can call it as process. That means programming execution. So now we are going to place P1 into one of the memory blocks. So what is the size of P1? That is 8K. And what is the size of memory block? 8K. That means the size of program or the P1 is exactly same as the size of the memory block. So we can place P1 in the first memory block. So we are utilizing the entire memory block. There is no wastage of memory. And second case, P2. In P2, what is the size? 6K. We are going to place 6K in the second memory block. This is the first memory block. This is the second memory block. All are same size, all are having the same size. We cannot change the size because that is fixed. Third memory block. And when we place P2 into the second memory block, what is the size of the second memory block? All are same. 8, but we need only 6K. So the remaining 2K, that is unused. The remaining 2K is unused. This is 2K, unused memory area. Only 6K is only needed, but the size is 8K, so 2K is unused. Then come to P3. P3, what is the size of P3? That is 9K. And what is the size of the third block? 8K. So we cannot place a 9K in 8K block. So the entire memory is unused even if processors are waiting in the job queue. Now we'll discuss about the disadvantages. So this unused memory location. In the first case there is no unused memory location. In the second case, when we loaded P2 into the second memory block, 2K, that is wastage. That means this unused memory space is known as fragmentation. So after placing, we have 2K wastage of memory. This is known as internal fragmentation. And here you can see that in the third case, P3, we have sufficient amount of memory, 8K and 2K. 2K is not part of the third memory block. 2K is the part of the second memory block, but that is not contiguous. So we cannot place P3 directly into the main block because the size is different. Because P3 need 9K, but we have only 8K plus 2K more memory is there, but we cannot use that. So this is not such kind of wastage of memory. This entire memory is known as external fragmentation. So these are the two disadvantages of fixed equal size partition. Next is the fixed unequal size partition that we will discuss now. Again, two memory area. One is system area and user or application area. Application area of memory. Application program area. In the first case, we partition the user or application area with equal size memory blocks. In the second case, fixed unequal size partition. From that we can understand that is fixed. Fixed means that we cannot change once it is set, but unequal size, that means the size of each block is different. That means block 1, the size of block 1 may be different from the size of the block 2. The size of the block 2 may be different from the size of the block 3. Sometimes equal size block can be there, like that. So now I am going to partition this user application area into different memory blocks. This is 10K and this is 2K and this is 8K and this is 5K. Now I have partitioned the user area of memory into 5 memory blocks. 1, 2, 3, 4. Not 5, 4 memory blocks. So first partition, the size of first partition memory block is 5K. The size of second partition is or memory block is 8K. The size of third memory block is 2K. The size of fourth one is 10K. Again, we have 4 processors P1, P2, P3 and P4 in the secondary storage device. And P1 is having the size 8K and P2 is having the size 5K and P3 is having the size 3K and P4 is having the size 12K. Now we'll discuss how we can place P1, P2, P3, P4 in various memory blocks. Suppose we are assuming P1 came first, P2 next, P3 third, P4 fourth. And P1 we are placing the memory manager. Memory manager is nothing but it's a collection of programs. Actually these collection of programs manages the primary memory. That means it knows or it tracks or it keeps a data structure that contains which are the memory blocks allocated to various processors and which are the locations or memory blocks free. So based on that only it will be loading the program from the secondary storage device into primary memory. Now P1, suppose the memory manager will check the size of the P1 with the size of each memory block. So when it compares with the first block, the size is greater than, the size of the P1 is greater than the size of the memory block, first memory block. So we cannot place, the operating system or memory manager will not place P1 into this memory block. So it will go to the next memory block, that is 8K. The size is 8K. So it will check the size exactly matching or not or less than the size of the memory block. Here the size is exactly matching, so we can place P1 here, So we use the entire memory block here. There is no wastage of memory. Now P2 state. P2 comes, it again will check one by one. So 5K is there, it will place here. P2 comes here, P2 comes here. So there is no wastage of memory. Then P3 comes, what to do? Again it will check, the first memory block is already allocated to P2, second one already allocated to P1. Then only 2 memory blocks that is free are, one is the memory block third, memory block 4. P3 comes, it will check the third one. So the size of the P3 is greater than the size of the memory block 3. So we cannot place P3 here. So it will be placed here. P3 will be placed here because the size of P3 is less than the size of the memory block 4. So P3 will be placed here. Then remaining portion, that is a 7K of memory. 7K of memory, that is wastage. That is known as the internal fragmentation. Then P4 comes. There is no memory space. There is one memory space, that is the third memory block, but the size of that one is 2K. So that is very small compared to P4, the size of the P4. So we cannot use this third memory block for anything, for storing any processes. So this is entirely waste. So the total memory, you can see that. So when we compare 7, you can see here 7 unused memory space and 2 is there, 7 plus 2, 2K. So these two are fragmentations. One is internal, total is known as the external fragmentation. So this is about fixed equal size partition and fixed unequal size partition. Now we will go to the variable partition. Again, two area, system area of memory, system area of memory, then user area of memory, user area of memory. Now we'll discuss the second method that is coming under fixed partition. Not fixed partition, contiguous memory allocation. So once again I am telling, memory management strategies are contiguous memory allocation, another one non-contiguous memory allocation. In contiguous memory allocation, again two types, one is fixed partition, another one is a variable partition. In fixed partition, again there are two methods. One is fixed equal size partition, another one is fixed unequal size partition. Both these methods we already discussed. Now we are going to discuss about variable partition. Variable partition. In variable partition, sorry, there is one mistake I made. Actually, these three methods are not a part of variable partition. These three methods are a part of the non-contiguous memory allocation. Non-contiguous memory allocation. Okay, now we'll discuss about variable partition. In variable partition, again we have two logical segments. One is a system area of memory, another one is a user area of memory. Will not be the operating system. That means the operating system will not divide into different memory blocks, and it will keep it as free, total free memory, and this total free or empty space is known as whole. Memory is known as whole. And at the time of requirement, what it will do, that we'll discuss. So now we have process P1, P2 and P3 and P4. And the size of P1 is 8K and the size of P2 is 9K and the size of P3 is 5K and this is 12K. And assume P1 came first and we are going to store P1. So it will start from here, it will allocate. There is no processes in the user area of memory before the execution of any program. So P1 will get placed here, P1 is placed here. What is the size? That is 8K. What is the size? That is 8K. And what is the next one? P2. P2 comes, next to 9K memory will be allocated for P2, that is P2. Then P3K, that is 5K memory, next to 5K will be allocated for P3. Then P4 will be getting 12K. So when we allocate in this way, we can avoid one of the disadvantages of fixed partition. So the disadvantages of fixed partition are internal fragmentation and external fragmentation. So what is internal fragmentation? The empty space or unused space inside a memory block after allocation is known as the internal fragmentation. Okay, external fragmentation means even though we have enough memory space for loading the program, but since it is not contiguous, we cannot use that memory space. So the total that memory space is known as the external fragmentation. External fragmentation we cannot avoid using this method, but internal fragmentation we can avoid using this method. Using variable partition method we can avoid the external fragmentation because here there are no blocks. So whatever comes first, that will be placed here. That based on the memory empty space. Okay, P1 came here, placed 8K. Then from this memory location we'll start the next process, and from this memory location starts the third, and from this memory location starts the P4. So we can avoid internal fragmentation completely using variable partition. But imagine, is it possible to eliminate the external fragmentation here? We'll check that. Suppose P2 completed, not P2, P3 completed its execution. P3 completed its execution. and P1 also completed its execution. So that means that memory space will become free. So now we have 8K, this is 8K because P1 loaded there, and this is P3, 2K, 5K, 5K is there. 5K is there. So what is the size of total empty space of free space? 8K plus 5K. That means 13K memory free. 13K free memory. Free memory. Okay. Now P5 comes, another process with size 10K. With size 10K. Can we allocate P5 into any of these memory locations or memory blocks? We have two memory blocks free. One is first one, another one is third one. First one the size is 8K and second one the size is 5K. And what is, so total how much memory is free? 8K plus 5K, that is 13K. And what is the size of P5? 10K. So that is less than 13K. But we cannot place P5 into these two memory locations because since this memory strategy follows contiguous memory allocation, the program must be inside one boundary. So 8K is there, 5K is there. Altogether we have 13K. But we cannot place entire program into one memory block because 8K, this is 10K, and this is 5K, this is 10K. So altogether 8K plus 5K memory space is free, that is 13K, but the size of P5 is 10K, that is less than the size of total free memory. Since we are following contiguous memory allocation, we cannot place this one there. So again, these two memory spaces are empty, unused memory spaces. It is known as external fragmentation. So using this method, we cannot solve external fragmentation. But we can solve internal fragmentation. Okay, so let me tell about these methods again. Not completed. There are different methods for placing the processes in various holes. We'll discuss that. So memory management is nothing but how the operating system or memory manager manages the primary memory efficiently and effectively. Okay, and for managing the primary memory efficiently and effectively, there are two methods. One is known as contiguous memory allocation, another method is known as non-contiguous memory allocation. In contiguous memory allocation, again there are two strategies. One is known as fixed partition, another one is known as variable partition. In fixed partition, again there are two types. One is fixed equal size partition, another one is fixed unequal size partition, and another one is variable partition. That is also the part of the contiguous memory allocation. This part I am not discussing now, non-contiguous memory allocation, where we will be discussing about virtual memory concept. Virtual memory is implemented using these three concepts: segmentation and paging, and segmentation with paging. And I have completed the fixed partition method, that is a part of the contiguous memory allocation. And we discussed already fixed equal size partition, fixed unequal size partition, and variable size partition also we discussed. Now we are going to discuss about what are the different methods to place the processes in the variable partition. Suppose now we have two memory segments free. One is 8K, one is 5K. Now P1 comes, P2 comes, and P2 comes. How to place P1 and P2 into these memory blocks? And the size of P1 is 3K and the size of P2 is 7K. So there are three methods for placing the new process into the free space. One is known as first fit. Next one is best fit. And third one is the worst fit. Okay. So we'll start with the first one, first fit. In first fit algorithm, P1 comes first, assume P1 comes first. So it will check with the first memory block whether P1 can be placed in the first memory block or not. That means the size of the P1 is less than or equal to the size of the first free space. If the size of the P1 is less than or equal to the size of the first free memory space, that will be placed there. So what is the size of the memory free space here? 8K. What is the size of the P1? 3K. So again, we will be placing here P1. So that is 3K memory only required. So what is remaining? 5K. This is 5K. This is 5K. Then P2 comes. P2 comes, can be placed here in the next memory segment? No, because the size of the next memory segment, that is 5K, that is less than the size of the P2. So for placing this one P2, there must be 7K memory at least. So it is not available here. Now it will go to the next memory location. Free space, memory space, free space, that is 5K. Can we place that? No, because this empty or free memory space, the size is less than the size of the P2. So we cannot place P2 here. So P1 comes means, okay, this is a first fit method. In first fit method, the memory manager will compare the size of the free memory block with the size of the process arrived. And if the size of the process arrived is less than or equal to the size of the free memory block, that will be